before I start talking. I do this every time, right? I'm gonna spend the first part of our session talking about the project. And then once I'm done with the project, I'm gonna leave the rest of our time. I guess I have to do the project, and then didn't we have a couple problems in 2F? No, we did those. Never mind. We got those done. I guess there's the one last one. I'll do that one tomorrow before we get into 3A. So I'm going to talk about the project. And then I'm going to leave the rest of the time to talk about homework questions, because I know there is a lot of them. So let's just get through the project, and then it'll be open questions to talk about those, okay? Okay, let me pull up the project. So the project for this unit has to do with the Earth, is called the Earth Area Project. And the reason why we have this project is because we are talking about unit conversion, basically. So there's part of their project will be doing unit conversion, and then but then it's allowing Google Sheets to do that work for you. So in your notebook, and does anybody have an idea of what page this is on? In your notebook?
151.
151. Okay, so on page 151, you will see these instructions: Earth Area Project. Okay, and then with that, you will see a layout that looks like this. Okay, and so this layout is already it's already created. And so you are going to be completing all the spaces that are blank. Okay. And I'm giving you the conversion factor from 1 kilometer to miles that I want you to use. And then you're going to use this in order to calculate the rest of this information. You'll be creating a pie chart. You'll also be calculating for percent of world population. And then if we go back to the project, you will, see if I can get this to blow up. So the first, all the stuff through inserting the pie chart is what's going to be on page 1 or sheet 1. Okay. The last part, percent of Earth's area covered by Montana. This business is going to be a new tab in your workbook. So you're going to create a new tab. You must use Google Sheets to perform your calculations and label all your values. You're going to use the internet to find the approximate area of Montana in square miles. And then you're going to use Google Sheets to convert this area to square kilometers. So again, you're going to be using that conversion factor between 1 square kilometer and square miles that you find in step 1 of the project. And then you're going to use the converted area to calculate the percent of the Earth covered by Montana. Then you're going to use the internet to find the approximate area of the United States in square miles. You're going to use Google Sheets to convert that area to square kilometers, and use the converted area to calculate the percent of the United States covered by Montana. Lastly, you're going to identify the population of the United States and of Montana, and you're going to use Google Sheets to calculate the percentage of the world population located in the United States and the percent of the world population located in Montana. Okay, so those are the parts that you're going to do on your own, that there's not really videos guiding you through. So if we look in our Eagle Online course shell, and we go to Let me pull that bad boy up. If we go to content, then we go down to unit 2. Then we scroll down to Earth Area Project. You will see that there is another copy of those directions and the rubric. This blank version, if we click on that, you'll see it's just a blank version of that layout in case you need it. For documents that come up sideways like this, if you click on these 2 arrows on the right and you click rotate clockwise, it will rotate your document for you, okay? And that's for all the normal documents that get uploaded. I'm still figuring out how to rotate the documents that get uploaded as an attachment to a grade item. For some reason, those are acting weird if they come from Google Drive. So I'm still working on that. But for all the other documents that are in here, if it is displaying sideways, on the right-hand side right here, there's these 2 arrows. Actually, hold on, it's not doing what I wanted. These 2 arrows right here, when you click those, it'll allow you to rotate sideways and that will flip it for you. And then if we go back to our project, we've got a video. And you get to hear and watch me walk through the video. So watch this to help you complete the video, okay? Or not to complete the video, to complete the project. Watch the video to help you complete the project, right? We know what Aaron is saying. And so that video is there. And then the last thing we've got is the assignment Dropbox, right? And with the last assignment or with the last project, you want to upload a copy of the rubric and then share a link to your project, right? Like we would share the link. The one thing I will tell you to change. So when we go in here to share it, when we click share, and remember there is you go to copy link, right? Let's see if I can get, we want to do anyone with the link. And then the one thing I'm trying to figure out where we can change the, oh, here, viewer, instead of viewer, I want you to click on commenter. And the reason why this is a good thing to click is then I can leave you comments in your Google Sheet on specific locations. So if there was an error in your calculation, I can click on where you made the error and I can give you a comment on what that calculation should have been. So instead of viewer, again, let's go through these steps again. So we're going to click share and we're going to choose, it comes up as restricted is your automatic. We're going to click on here and go with anyone with the link. And then on the right hand side, the automatic one is viewer and we want to choose commenter. And then you would click here and say copy link. And then that would be what you would copy over into your assignment Dropbox.
Let's just do again because I think the date changed on it.
What? I'm sorry?
What was the date? What's the due date on this? I think it changed again.
The due date did not change, or it should not have changed. Where's my little map?
I might have looked at it wrong. I'm just making sure.
Okay, the due date is October 13th. And so next Thursday, a week from tomorrow.
Thank you.
Yeah, and so it shows it here in the assignment box, October 13th. So, any questions about the project? Okay, so what I'm gonna do now is I'm going to go through homework questions. Okay. Because I know there are a plethora of them from 2D.
Let me find the one I was struggling with in my math lab and I'll pull it up and tell you.
Sounds good.
I think that as far as like the ratios go that we are making, it just takes me a minute to figure out what to plug in where, but for
Mhm.
some reason I just couldn't wrap my brain around the watt problems. I don't know, maybe it's because I'm not familiar with that at all.
Mhm.
But I really was struggling last night, like a lot. So
That's
let me
okay.
find it.
So let's see, the first watt problem is, looks like number 6, the utility company charging money to keep the light bulb on, and how much do you save by switching to a lower watt bulb? Is that okay? So again, the numbers that I have might be different than the numbers you had in your specific homework assignment, but we can follow these steps, right? So my example says your utility company charges 11 cents per kilowatt hour of electricity. And then it says completes part A and B below. A is, what is the daily cost of keeping lit a 150 watt light bulb for 8 hours each day? So the first thing we need to recognize is that we're finding the cost, right? Which means we're going to have to use this charge that they're providing from the very beginning. You know what I mean? And the other piece we need to recognize is that the charging rate is in kilowatt hours, but our bulb is just in regular watts. And with energy, or with anything that has to do with energy, when they're giving you, just when it says 150 watt light bulb, or later when we talk about the power plant and it's saying how much power it can generate, it's always in a measurement per hour. So when they're saying a certain number of watts, that's how many watts it uses in 1 hour. So when we've got our 150 watt light bulb,
That was part of what confused me, is it was saying that, like, one of my problems was saying that a company used like 460 watts or something.
yeah.
But I didn't know if that was like in a day or in an hour or in a minute. So it was also
Yeah.
confusing.
So with that, when we're talking again about power usage, that power usage is per hour. So for this first bulb, we need to convert it from watts to kilowatts to be able to use the price that they give us. So we're going to multiply this as 1 kilowatt over 1,000 watts. So the reason why we have 1,000 watts, remember kilo means 1,000, so 1 kilowatt is 1,000 watts. Multiplying this through, we end up with 0.15 kilowatts in 1 hour. So that's how many kilowatts that bulb uses to stay on for an hour. So we don't care about the price for 1 hour, we care about the price for 8 hours. So we're going to take our bulb And we're gonna multiply it by our conversion factors. So we have two of them. One is 11 cents per kilowatt hour. And the other one is 8 hours in 1 day. So thinking about what unit of measure we need to cancel, we've got the 8 hours in 1 day. And then we've got 11 cents per kilowatt hour. So this first conversion factor gets rid of our hours, and the second conversion factor gets rid of our kilowatts. Because again, our units of measure have to be diagonal from each other in order to cancel out.
So even if the fractions are not next to each other, as long as there is a kilowatts in the denominator and one in the numerator, they cancel.
Yes,
Because you're ultimately multiplying, so you can move them around.
exactly.
Okay.
And if you feel uncomfortable with putting them all in one line, you can do just 2 steps and then 2 steps and 2 steps. But the one thing I always warn is don't round in between, because if you round what we refer to as intermittently, which means as you're moving through, if you round different steps, ultimately your answer at the end will be off. And so that's why I say keep them all in one long line so that you don't round as you're moving through it. So we multiply this, we've got 0.15 times 8 times 0.11, which is going to give us $0.132 or 13.2 cents is how we would read that per day. So that's how much it costs to keep that 150 watt light bulb on for 8 hours a day, right? Your instructions in the little parentheses says round to 3 decimal places as needed. So we would use that full answer there. The 0.13, we would use 132, excuse me, we would use all of that. So part B says, how much will you save in a year if you replace it with a bulb that only uses 20 watts of power? So before we can get to the savings in a year, we need to come up with the cost to keep that 20 watt light bulb on for 8 hours a day. Because they're saying your usage is going to stay the exact same, but instead of using a 150 watt bulb, you're using a 20 watt bulb instead. Okay.
That was something I missed last night too, then. That's something I messed up last night in my problems too.
Yeah, so again, I realize that it's not that they're intentionally being vague. They just don't want you to, they're not trying to add in even more information. They're saying, okay, we're still doing everything the same. Instead of using this 150 watt bulb, we're now doing the 20 watt bulb. So we're gonna have to go through all of these steps again, but instead of starting with 150 watts, we start with 20 watts. So our first step is going to be, we're going to put those 20 watts over 1 hour. And we're going to multiply by the 1 kilowatt over 1,000 watts. So what that's going to do is give us 0.02 kilowatts in 1 hour. Because again, dividing by 1,000 moves our decimal place 3 times to the left. And once we have that, we're going to then continue on with the steps we did in this last row. Okay. We're going to do 0.02 kilowatts. In 1 hour. And we're going to multiply it by 8 hours in 1 day. We're going to multiply it by still that 11 cents per kilowatt hour. So 0.02 times 8 times 0.11 gives us 0.07, or excuse me, 0.0176. So we zoom out a little bit. The 150 watt bulb, it cost $0.132 per day. The 20 watt bulb costs $0.0176 per day. So to ultimately get our savings in a year, we figure out how much savings we have for just one day. And the savings for one day is going to be 0.132 minus 0.0176. A good way to monitor the validity of your answer is that the amount of money for the lower watt bulb should always be less than the amount of money for the first bulb, right? Like we should have a second number be less. So if you end up with a price that's more than the first bulb, then you know you made an error somewhere, because if we're reducing our wattage, we should be reducing the cost for it as well. So 0.132 minus 0.0176 is going to give us 0.1144 in savings. So theoretically, in a year, we're leaving this bulb on for 8 hours a day, every day for 365 days. The reason we use 365 days is because that is our standard unit of time for a year. Yes, I know that there's one leap year where we have 366 days, but we're ignoring that. Much like whenever you calculate anything for a month, we use 30 days as our time period for the month, because that is the standard unit of measurement for a month. So taking that 0.1144 times 365 gives us $41.756, and they're going to want you to round to the nearest cent, which is 2 decimal places. So approximately $41.76 in savings.
So, Erin, if I go in today and finish my homework, because it booted me out last night and I just turned it in because I was confused and needed to talk to you about this, will I have 15% taken off of my total?
I can change it so that you can still work on it today.
Okay, thank you.
Yeah.
Yeah, I would like to go in and fix it just because I was really struggling with these ones. I don't know. This makes more sense though.
You're not alone. I got a fair number of emails last night, so don't even worry about it.
Okay, it makes much more sense with the watts that they give us being per hour, because I wasn't sure what that measurement was.
Right, I understand. And that's part of it, is just knowing, what do they mean, If I could add a little blurb to the problems, I would, but unfortunately I'm not able to, you know what I mean?
Sorry, I didn't mean to interrupt.
Go ahead.
When we take this quiz, is there any way we can use notes?
So you can always use your notes on your quizzes.
Oh, on quizzes, well, even for, okay.
Yeah, it's
This
tests that you
part was
can't.
just hard.
Well, and I will say the homework problems are harder than the quiz problems.
Okay.
So the other one that had to do with watts was I guess there was the outdoor spa, but the one that was weird was number 9 that most people struggled with. So let's talk about that, about the coal burning power plant. Is that one that other people have questions on? Okay. So Kaylee, I'm using the numbers from your specific homework assignment because I just went in and changed your settings. So it says a new coal burning power plant can generate 2.2 gigawatts. And then it says in parentheses, billion watts. What that means is the word giga is billion. And so instead of billion, remember billion equals 10 to the 9th. So that 2.2 gigawatts is really 2.2 times 10 to the 9th watts. So it says a new coal burning power plant can generate 2.2 gigawatts of power. What this means is in 1 hour. Again, if it's giving you a unit of measurement in watts, that always has to do with how much it needs or uses or generates in an hour. Okay. And so it gives us a whole bunch more information, but we're going to focus on just part A, which is how much energy in kilowatt hours can the plant generate each month. So we are given how much it can generate in watts in a month, but we don't care about watts. They care about kilowatts, right? So that means we need to take our 2.2 times 10 to the 9th watts, and we're going to convert it to kilowatts. Now remember, 1 kilowatt is equal to 1,000 watts. But because we're dealing with 10 to the 9th already, this is going to make your life a lot easier by, instead of doing 1,000, we do 10 to the 3rd. Because having those powers of 10 allows us to cancel those exponents out more easily. So we're going to do 1 kilowatt over 10 to the 3rd watts. When we do this, 10 to the 9th over 10 to the 3rd, those cancel, and we end up with 2.2 times 10 to the 6th kilowatts.
And that's per hour?
Per hour, yes.
Okay.
So we can say that's over 1 hour. And if you want, you can put 1 hour here too. So in part A, it says how many hours per month. So we're going to take 2.2 times 10 to the 6th kilowatts over 1 hour. And we're going to multiply it by 24 hours in 1 day and 30 days in 1 month. Because our standard unit of time is going to be 30 days for a month. So when we multiply that, we're going to take 2.2 times 24 times 30, which gives us 1,584 times 10 to the 6th kilowatts. Now, the space, like, remember when you're looking at where you're giving the answer, there's a box, and so it says, part A says, the plant can generate blank million kilowatt hours each month. 10 to the 6th is million. So what this is telling us is that it can generate 1,584 million kilowatt hours. So the only piece that you need to enter is the 1,584. So if anybody wrote in 1,584 times 10 to the 6th, I'll fix it. Just let me know, because what you're basically saying there is that it's 1,584 million watts, and we don't need their redundancy of million. Okay. So then part B says how much coal in kilograms is needed by this power plant each month. So part B, we have to go back to the problem, and it says burning 1 kilogram of coal yields about 460 kilowatt hours of energy. So we're gonna take our, how much energy it can put out in a month. 1,584 times 10 to the 6 kilowatts. And we're gonna multiply it by this 1 kilogram over 460 kilowatts. And the reason why we're multiplying it by 1 kilogram is this is kilogram of coal. So that's going to give us our energy usage in kilograms. So
You wrote 406 in the denominator.
What? Oh, I need 460. Thank you.
Mhm.
See, I'm just thinking about Montana, 406, right? Just kidding. It just is my dyslexia. I wrote down the numbers wrong. So 1,584 divided by 460 is going to give us 3.4434786261 times 10 to the 6 kilograms. Now, again, how do I know I don't need to use that 10 to the 6th part? Well, if you read the question, like where you put the answer in, it says the plant needs blank million kilograms of coal each month. So again, this is the million part. And so it wants us to round to 1 decimal place. So we're going to have 3.4 million kilograms of coal per month. And the last part is part C. Of course, I've got to get it to show me all the parts. We'll do it in here. Hold on. Let me wait 1 second. Actually, Kaylee, can you go in and enter the answer for part B on your homework in number 9?
Sure. What question was it?
Number
again?
9.
Number 9. Okay.
Mm-hmm.
So part B is
3.4. Let me know when you're done, because I was working off your specific problem and it won't show me part B until,
I answered it, but then here, let me refresh it.
yeah.
It might just because I'm reviewing it.
Oh, yeah, you got to go back in and actually,
Yeah, let me go in and it won't let me enter in an answer. Let me look. Hang on.
yeah, because you
I'm
got
gonna mute it because I'm at the daycare, so it's kind of loud. I'll
okay.
pop back on when
So part C is going to ask us about how many households we can generate. And I'm the only reason why I'm waiting is because I want to make sure that I get the like amount that is associated with these specific numbers, or else the work is gonna be off. So I'm just gonna wait a hot minute until we can look at what
I put in the answer.
you put in the answer.
Yeah.
Okay. Okay, so if a typical home uses, so part C says if a typical home uses 1,004 kilowatt hours per month, how many homes can this power plant supply with energy? So it's talking about the energy. So we did the work in part B in terms of finding how much coal we needed. But because we're still talking about the energy, we're going to go back up to the amount that we had in part A, which is the 1,584 times 10 to the 6th or million kilowatt hours. And we're going to multiply it by 1 house over 1,004 kilowatt hours. And because what we're trying to say is, here's all the energy we have, how many houses will it feed? And if each house uses that 1,004, we're gonna divide that into it. So
So you can really put whatever measurement you want in the numerator and denominators. It doesn't have to be like your typical measurement then.
yeah, no, because all we're doing is we're talking about a ratio.
Okay,
And so what this is doing is that we're gonna cancel our kilowatts and our answers is gonna be in terms of houses.
okay. So do kilowatts and kilowatt hours, do those cancel each other out then?
Yes,
Okay,
so they mean the same thing.
okay. Yeah, I wasn't sure. I don't know.
So when we multiply this, we end up with 1.577689243 times 10 to the 6th houses. So at this point, when we read the answer or where the question needs to go in, it says the power plant can supply blank homes with energy. And so they want us to round to the nearest whole number, which means we actually need to take that and multiply it by 10 to the 6th. Because we need to actually, instead of reporting our answer in millions, we need to report the actual amount. So multiplying it by 10 to the 6th gives us $1,577,689.243 homes. They want us to go to the nearest whole number. So we're going to say approximately 1,577,689 homes. Okay, other homework questions?
If nobody else has a question, I would like to work on, since we're here, one of the, let me find it real quick. It was the one about people, the population ones. And I think I ended up getting it right, but it took me a few tries.
You're talking about the mortality rate for number 1?
Yes, that one. Maybe I didn't get it right.
Okay.
Yes, that one.
Okay. So my example for number 1 is, suppose that in 2008, 713,450 citizens died. Can't be uplifting. We got to kill people off. Assuming the population of the country is 299 million. So remember, 299 million is giving us 299 times 10 to the 6th. What was the mortality rate in units of deaths per 100,000 people? So, first of all, we want to take the number of citizens. We want to divide it by the total number of people. And this is going to give us our rate of death per person. Now, when entering this into your calculator, if you want to make sure that you get it to do all the steps properly, you would want to do 713,450 divided by, and in parentheses, 299 times 10 to the 6th. And the reason for that is that if you just type in 713,450 divided by 299 times 10 to the 6th, what your calculator is doing is it's dividing by 299 and then multiplying by 10 to the 6th. you need to make sure that it knows that it needs to divide by all of that stuff in the denominator, or you need to first convert it to millions before you divide it. So dividing this, we end up with 0.002386124 deaths per person. So now we're going to take this and we're going to multiply it by 100,000 people. Because we're trying to figure out how many deaths per 100,000 people. We come up with 238.6120401, and they want you to round to the nearest integer or whole person. So we're going to do 237 deaths per 100,000 people.
Would it be 237 or 239?
Oh, sorry, 239. Yes, apologize. 239. An alternative way to solve this is you could say deaths over population equals deaths over population, meaning if we set up a proportion, we can have 713,450 deaths and a population of 299 times 10 to the 6th equals X number of deaths out of a population of 100,000. You're still ending up with the same process because you would end up still multiplying by 100,000 and dividing by 299 times 10 to the 6th. Okay. Either of these setups is going to get you the answer. The first setup, though, the one I have written in green, that's most consistent with what we've been doing in terms of using unit conversions. But setting it up as a proportion would still work too.
Okay, thank you. That helped a lot. I feel a lot better about the homework last night.
Okay. What other questions from everybody else do we have?
I have this calculator.
Uh-huh.
Can I do the 10 to the power of 6 on this thing? Does anybody know?
Let me see if I can.
You should be able
So
to
you
put
see how
10
you've
here.
got the X to the Y?
Okay, yeah.
So you would enter 10
Oh,
and you'd press that and then you would enter 6 and that'll give you 10 to the 6th.
okay, thank you.
All the calculators, right? Like they all have a little bit different way of working. Other homework questions?
No, but thank you for letting us know to put it in parentheses when we're on the calculator, because that's why I kept getting it wrong.
Yeah. And that's where, I mean, like that's where calculators are not infallible, right? I always joke, I'm like, they're only as smart as the person using it, but that's rude to say too, because you know, it's indicating you're not smart, but we are. It's just knowing that what makes sense in our brain versus its very simple brain doesn't always add up. And so it's like, you have to literally tell it what to do so that it follows order of operation as you want it to, versus where it's like, well, I just divide and then I multiply and I'm done. It's like, no, you have to do this first, then do the other thing. So yeah, especially you using those parentheses so that you're telling it, do this piece first, then do the second piece. Without those, you'll have a whole bunch of frustration. At the end of the semester, we talk about calculating monthly payments for loans and credit cards. And there's a very complex formula that we use for that. And that's where using parentheses becomes very important, because you can enter it once and it'll do it for you, but you got to make sure you put all the bits in the right spots, or else, you know, again, the calculator has its own mind and does it for you.
I think you put instructions on Eagle Online too in 1E
Yeah.
for calculator like settings and how to
Yeah,
enter.
1E had to do with when we were finding mean, median, and mode, and how you use the calculator to do that specifically. Not necessarily just like generic calculator usage.
Oh, I thought maybe that's what it was.
All right. Well, that is our time, everyone. So if you do have questions still, let me know, send me an email. And I will see you all tomorrow.
Thank you very
Thank you
much.
so
for your
much, Erin.
You're welcome. Have a good day, everyone.
Bye.
Bye. Melissa, are you still trying to write something down?
I think I got it. Thank you.
Okay, you're welcome.